The geometric probability density function tells us the probability that the first occurrence of success requires X number of independent trials, when the probability of success on any one trial is P. In other words, you keep repeating what you're doing until you first succeed. Then you stop. For example, you throw a dart at a bullseye until you hit the bullseye. The first time you hit the bullseye is a success, so you stop throwing the dart. It might take 6 tries until you hit the bullseye. You may think of the trials as failure, 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 success, then stop. If the probability of success on each trial is P, then the probability that the Xth trial out of X trials is given by the formula. All we need to know is the probability of success in one trial to find the probability of a string of X minus 1 failures before the success. This probability density function assumes that, like the binomial, the trials are independent events. In the case of throwing the dart, we assume that the person does not learn from the experience of throwing. We can see that this is a very close relative of the binomial because it assumes independence of the trials, the random variable is discrete, and there are only 2 possible outcomes. Here's an example. One often hears sports announcers, particularly in baseball, say that a particular player is due, somehow meaning that he has failed multiple times and now he should have a success. In baseball, this is often part of the discussion when a player comes to bat and has not had a hit in recent times. Maybe this is just a form of encouragement from the announcers. Assume that the batter has a historical batting percentage of hits to times at bat of 28%. By the way, this is not a batting average. Would we be surprised to know that this player has just hit for the first time in 5 times at bat? Here we are asked for the probability of a streak of 4 failures and then a success, the just now accomplished hit. This is a classic geometric probability problem. It is a discrete random variable, the number of hits. The random variable is binary, hit or not hit, and we are asked for the probability of a streak of failures. Now using the formula we have, P is the probability of a success, equal to 0.28, in any one time at bat, and X is the number of times at bat before the first hit on the 5th time at bat. Entering the numbers into the formula, we have P of X equals 5 equals 1 minus 0.28 raised to the 4th power times 0.28 equals 0.0722. No, we would not be surprised with a hit. The probability of a streak of 4 failures before the next hit is only 0.0722. Thus, the probability of a hit, a success on the 5th time at bat, is 1 minus 0.0722, or 0.9278. One important note, in such events as the performance at bat, the assumption that the current performance is independent of previous performances is a big stretch. It would be hard to say if the past failures created more attention to the ball and concentration for a better result, or more anxiety that results in a failure. In any case, this would violate the assumption needed for the geometric distribution. But it's fun to play with these types of questions anyway.